Okay guys, so we started with the slope deflection equations. We covered the concept, the equations, then we went over an example last lecture. Then today there's another example. So we go over examples. We have the following beam. Beam A, B. Fixed at A and roller at B. So it's indeterminate to the first degree. Indeterminate to the first degree. We have one extra unknown, right? We have one extra unknown. The question is find the reactions and draw shear and moment diagram for this beam. With this method, this beam is direct, right? هاي الطريقة اللي أخذناها الحل تبعه دائما. Right? You have this beam calculated for you. The moment here will be what? And you're looking for a moment here. If I tell you, look, what are the unknowns? We have AX, how much? 0. We have AY. We have M at A. Could be in this direction, could be in another direction. We have UI. Right? So if I tell you, and I know one of the unknowns, I know what's BY, then we solve it. I know what's MA, then we solve it. Do we know any of those? No. You don't? Do you have the sheets at the end? Okay, now, no. The other day I said there is MAB, there is MBA, right? That's it. There is MAB, there is MBA. This is what we do with this method. MAB, MBA. Now, this is end span, right? We know the moment here is 0. The moment it's spin or roller. So the moment here is 0. So we don't have to fix this one. So the moment here, it is the fixed end moment. MAB is the fixed end moment at A. What is the sheet? W. Direct from the right hand side, من اليمين, direct. You have it, it's given. And once you have something like this, you don't have to go with the equation. This is given to you directly, go for it. Okay? So you calculate M, then you find those two. Calculate M, then you find those two. For any question with one span, we have it. We have it. If I fix this one, fix, then you are on the right hand side. And you mean, sorry, on the left hand side. Left. This is both spans fixed. For any loading, everything is given to you. Not only for any loading, for any settlement, there's a settlement. It's given to you. On the right hand side, if one span is fixed and the other one is spin or roller, it's given to you. So in this case, the table gives us this one for it. Look, now you have distributed and you have concentrated 5 meters. Let's say it's in the middle. The equation will give here, this one is given distributed for both. So we use the principle of superposition. For distributed, how much? WL square over A in this direction. What if you have this one? 3PL over 16. So if we have a distributed load, there will be a moment here equal WL square over 8. If we have a concentrated load, we will have a moment here 3PL over 16. We have both of them, then we'll have this and that. They both cause moment in the same direction. is 20 times 10 square over 8. Of course, yeah. There you have force. So this is WL square over 8 is how much? 20 times 10 square over 8. 250 plus 3 times 100 times 10 over 16.
1187 ونص. لا 437
check يا check Newton meter. So واحد يقول is this positive or negative? That's it. This is the direction of the magnitude. You don't have to say it, positive or negative. The method, we don't care about what's MAB and BA. We use this equation to find the exact ones, the real reactions. Now you have the real reaction. ليش بدك تروح على؟ You get it right there. If this is MAB, it will be negative. If you are looking for MAB, it will be negative. Right? Be negative. And you can apply the equation. Easy. You can apply the equation. Right? Right? What's MAB? Let's apply the equation. What's MAB? What? 3EI over L theta A, which is minus psi plus F D M. Right? What's theta A? 0. Fixed. What's psi? 0. So this is gone. So it's the fixed end moment. The fixed end moment in span AB at A. The fixed end moment is what? Counterclockwise. So this one will be how much? Minus 437.5. That's MAB. If it's positive, if you get it positive, it means clockwise. If you get it negative, it means counter. It's straightforward. Direct. Okay? So if this is the case, this is 437. Take sum of the moment here equal to 0, you find the reaction. Sum of the force in the y direction equal to 0, you find the other reaction. If we take sum of the moment at A equal to 0, the distributed load will be 20 times 10 to 100 times 5. 100 times 5. Those are clockwise. This is counter. So 20 times 10 times 5 plus 100 times 5 minus 437.5 divided by 10 equal V1. Divided by 10 equal, sum of the moment equal to 0. 100 times 5. 20 times 10, that's 200 times 5. 106, 125. If this is the case, sum of the force in the y direction equal to 0. This is 100 and 200, that's 300. Minus 106. This is 150. Fine. You need to fix your numbers.
السؤال تطلع 125 ديوان 106
مين محوش آلة حاسب؟ مين محوش آلة حاسب؟ دول جايين على هندسة، معاهم محوش آلة حاسب دول جايين على هندسة. روح اقرا تاريخ ولا جغرافيا، شو كتب الهندسة؟ مهندس بيجي على جهة محوش آلة حاسب. دي واحد كم دي واحد؟ 106 الناس بيجمع حاجة قلم. الدكتور عصب إنه نستغرب من عصب وصلنا. طبعا الشيت اللي من الصبح اول ما بامريكا وديت لكم تجيبوا الشيت نصكم معهم شيء صح؟ ما اخذناش مكان يعني على الباصات علينا نصهم معهم شيء هذا لا يهمنا انت واحد منهم صح؟ وينها؟ excuses 193 175 right? Shear up. Then you go how much? 100, right? 25, that's 100. 193, so you go to 93, 175. Then you have a jump of 100, you go to 6, 25. Then you go to 106, 125, that's your shear. Positive, negative. Then we have negative moment 4, 3, 7.5, negative moment here. Then we move from here to here. We have positive area. We have positive area. How much is this area?
جزئين.
Trapezoid. The average of those two, the average, it means this plus this over 2 times 5. Distance between them. How much? This is the area, right? Minus 437.5. 281.25. Okay. How is this now? Okay.
Get down.
Get down. Okay. Okay. It should be 0. This area, 6.25 plus 1 or 6.25 divided by 2 times 5 should give you this. 281. So that's positive and that's negative. That's positive and that's negative. That's positive and that's negative. Why is concave this to concave this way? Why is concave down? We said we test the slope, right? So the slope here of this curve is how much? Plus is the shear. Slope, you don't just close it, is the shear here. So it's positive, right? So I said, so the slope here is the shear here. Or here.
Positive shear, positive moment.
Good. So we have positive moment. Okay, say that. The slope. Why do you have a slope here equals 0?
Maximum moment at 0 shear.
What is the 0 shear?
I need to
Constant.
You know, guys, you know this one is the actual one is.
rule.
To the left, 93.75. To the right, 6.12. At 0. Like very small point. 0. So the slope is 0 to the horizontal line. Yeah, this width there is the width of the loading. The loading cannot be point. It's like 1 point is 16. It's like half width, like عجل, with tire of a car. There's a contact area. The surface. Good? So this is how it looks like. Now if someone is telling you this is not enough, by the way, this is not enough moment diagram in the real life. في الحياة this is not enough, صح؟ كامل ولا مش كامل? Is this enough? There's something bothering you, right? Just making imagine. There's something missing, صح? What is it? When it change from, at what distance it will change from positive to negative? Right. You should tell the guy this is negative moment, this is positive moment. He need to know where to stop the steel if we're designing reinforced concrete. So how much is this one? How much is this one? Right. How do you know this? No, x bar or what do you know about this point? Moment is zero. I just take a section. That's my x. We should do this. This is 437.5, and this one is 193.75, right? And we have this distributed load. Distance x. The distributed load is 20 kilonewton per meter. This is distributed. So what do we know? We have shear here, right? And how much the moment? Zero. That's your point. The moment is zero. The moment is zero. So if you take sum of the moment here equal to zero, sum of the moment here equal to zero, you will be able to find this one. So sum of the moment at this point, O, equal to zero. If I take counterclockwise positive, give the following: 437.15. Counter, it means positive.
Minus.
Then 20 x times x over 2. That's also counter. So plus 20 x squared over 2. Then minus 193.75 x minus 175 x equal 0. If you simplify this one, you will get x squared. Look, I divide by 10, right? And height 20 over 2 is 10. So x squared, I divide everything by 10. To bring this one, become 19.375 x, right?
X بتطلع 2.6.
Plus 23.75. 2.6.
دكتور تنحل عن الكالكوليتر شوف شو.
هسا انت بتعرف تحل على الكالكوليتر. You can do it. غيرك cannot do it. How much you get on the calculator?
2.6.
ها؟
2.6.
Wrong.
تطلع دكتور 3 فاصل 4.
شوف ما لنا جواب.
3
Wrong.
261. 16.7.
2.6. Wrong.
24
16.7.
في واحد حطنا حل صحيح.
اكثر من 24
مين مين اول واحد حكى؟ شو what
2.6.
say 2.61 who can second him؟ مين يقول 2.6 just 1 point the calculator gives you 1 point so this curve if it was continuum it will touch at another point here because it will have the solution will be plus minus the solution will be plus minus one of them we don't know one of them is not real واحدة من الحلول اللي هي x is not real sometimes you have the curve touching at 2 points so it gives you both points so you know this right
بس 16 عندي انا طوله 10 فعشان هيك
good good and that's my question that's my يعني like you know sometimes you have two answers so give you both answers is it 2.61 so in 2.61 the beam should have reinforcement at the top after that the reinforcement should be at the bottom
يعني ما اشتري بس شو اللي كان.
sometimes you have the curve like this I'm sure this is a curve the equation is x squared you have two solutions x equals something plus minus sometimes you get minus it means trivial the solution you take the other one now you get 2.61 and 16 you know the 16 is out of the beam dimension but sometimes you get like 2.6 and maybe 7 so you know there's 2 points touching if you have a beam this beam this beam with a cross section يعني الرابع beam طلع عليه cross section يعني بيكون هيك usually the higher depth is this way so it gives you higher inertia so it doesn't deflect much can deflection is We'll learn this in reinforced concrete, but just to tell you what we are doing. This fixation could be in a wall, جدار, or in a column. So it's fixed. Fixed here. So we said over a distance of, this is 10 meters, right? Oh, sorry. This is fixed, and sitting on a support. Sitting on a support. Could be something here, you see like kind of a roll or something. Look at the bridges, طلع على الجسور, you will see that the beams are sitting on the piers, the walls. See they're sitting on them. Means it's free to move in this direction, but cannot go down. So this is a roll. This is a roll, just the beam sitting. And this is fixed here. This is fixed. So we said the reinforcement up to 2.61, the reinforcement is top because the moment is negative. So you design it for this one. You calculate the reinforcement based on this one. For this. Then you calculate the reinforcement in the positive region based on this positive moment. Now how about the cross section? The cross section, when you design, you need to calculate B and H. Then find how much steel you have in the positive and how much steel you have in the negative. Anyway, just to let you know. So we have something like this. Have to fix it. And something like this. This is how we see the steel. This is for the negative. And not one bar, multiple bars. Multiple bars, but they are anchored. They are anchored here. Yeah, to create a fixed support. To create a fixed support.
دكتور ما مش بيصور المساحة المعادلات
وين؟
ليش تسحبوا
وين؟ هون؟
لا
ايه؟
كون كونتينيو بس ما لي تحت.
ستوب بس بطل يمسح. كلف اكثر بس كات. بس more anyway, that's easy one. For anyone, any problem, actually, a beam, even view like this, any beam, fixed, for any loading, the fixed moments are calculated for you. They are calculated. And the only thing you need to do is find those. Okay. So if you give you a case with fixed with any loading, you should be able to solve it. You should be able to solve it. Good? From the left, when you have both fixed. From the right, when you have both one end fixed. You have two span. Another example. You have two span. B. A, B, C. Span A, B has concentrated load. Span B, C has distributed load. Find the reactions. Draw the shear moment diagram for this one. Okay. It's straightforward. So this is an end span with the far end pin. and that's an end span with the far end relevant. So one equation for, we don't need MAB, we know it, 0. We don't need MCB, we know it. So we just need to find MBA and MBC, and we know MBA plus MBC equals 0. Then we find theta at B, then we find everything. But let's see. So MBA equal 3, EI is constant. EI is constant. 3 EI over 5, right? Theta B, psi equals 0, no psi, right? Plus the fixed in moment in span BA at B. The case when you have one fix here with the load in the middle. And you will see it also on the right, but we will have the fix here and the pin here. It's the same. 3 PL over 16, the same. But it will be here. No, it will be here this way. Now, this is what we have. This is what we have. This is our case, right? We fix this. Right? Now, our moment will be this way. Is this positive or negative? Positive. Is it positive or negative? Positive. So 3PL over 16. If you do this, 3 times 60 times 5 over 16. How much? 56.25. That's our first equation. Second, BC equal 3EI over 6 theta B plus the fixed and moment BC at B, which is this is your case. This is your case. If you have W, this is like this, WL squared over 8. This is the case. Now we are fixing this. I'm looking at this. So the moment will be this moment 45 in our equation minus 45. See guys? Easy work. Be careful. Easy work. Be careful. This plus this equals 0. MBA plus MBC equals 0. Those plus equals 0. It means this plus this equals 0. And the second, the compatibility MBA plus MBC equals 0. That's your third equation. And for this we have look, I want to make this factor 30. Make this factor 30, then subtract. Now we need to add. So to add them, the common factor is
مع الآن بيطلعوا واحد خاص بواحد.
we're gonna just do it for them just to see how we did it. Listen, he said you don't have to do this. This is 3 over 5 is 0.666, right? And this is half. So 0.667 whatever plus 0.5 something, which is 1 point whatever. And this one, when you add it to this one, it will be 16.25. So what I have here, 0.66 whatever plus how much? 1.67 theta B.
دكتور 1.1 بالضبط.
دكتور 1.1 بس 3
3 over 5 is 1.6. Alright. EI, right? Plus 56.25 minus it. When you add this plus this one, you get plus 16.25 equal 0. So theta B is minus 16.25 over 1.1, 14, 16, 17.
شو مستاهل الدكتور؟
نيجاتيف.
بس دي
11
شو معنى؟ That's 11. 11.
يطلع 10 و 22 10 و 22
10.22 over AI negative. It means count. And we can tell it's counted. Now we cannot tell. So look. If you have the load here, this will go down and this will go up. If you have the load here, this will go down, this will come. You can, for this case, you can tell. If this is bigger than this, it means this will go up. So 10 times 6, 60. They should be almost the same. But our calculation showed minus 10.22, right? Our calculation showed minus 10.22, which means this rotation is clockwise. Means like this. This is a clockwise rotation. Right? That's a clockwise rotation. Huh? No, we did not say. This is distributed, this is concentrated. This is distributed, this is concentrated. If they were concentrated, this would not move.
Concentrated, uniformly distributed.
I don't know, this is the calculation showed us. And by the way, this is, I'm not sure, this is a very small number, could be a very small number. And this is not big, that big, very small. But this is how you tell. This is how you tell. On this side.
سؤال سمعي بس عندي فقطها مع عقاب الساعة طلعت مع الساعة المفروض يعني عكس عقاب الساعة صح؟
وين فرضت
مع عقاب الساعة بالبيت الأول
ما انا ما فرضت شيء، انا اشتقيت شيء اسمه ثيتا، رايت؟
تمام
اشتقيته اول مرة، شو قلت لك عنه؟
أول مرة
معادلات يعني اللي اشتق معادلات ستوب ديفليكشن ايكويشن اللي قايل اللي درايف مش انا اللي اشتق، شو قال عنه؟ شو قال عن ثيتا بي؟
ثيتا بي اللي هي
قال عنها if it's clockwise positive.
تمام
We calculated theta b.
طيب
We get it negative. What does it mean?
يعني هي كم؟
أنا ما فرضتش، وين أنا فرضت؟
فكرتك أنا دكتور طلعت أنا على البي إم عند ال
مش فرض أنا هاي والله مومنتس يا عمر، أنا مش فرض شيء.
أوكي
أنا فرض شيء، أنا فرض روتيشن يا جماعة. So if this is minus 10.22, we come to any equation here. 10, by the way, the EI will cancel now. See, the EI always, يعني ريح راسك, the EI always cancel. So minus 10.22 times 3 over 5, which is 1/6. Added to this one, you give you MBA. How much? 50.11. And this should be minus that number as a check. This should be minus the number. You check it? You did? Check to her. This should be minus 50.11. If not, something is wrong. See? Good. So now this is what we have. This is what we have. هذا عندي سؤال. You have a question? Rotation. No. You mean deflection more? So we get it negative. It means count. We get it negative. It means count. Right? We get theta negative. It means count. It means it went this way. That's counter. If this one went this way, This for continuity has to go the other way. And this makes more sense. This makes more sense. يعني أنا الصحيح 60 concentrated in the middle has more effect than 60 distributed over the length. You have the full load at one point. Yeah, if you have the same span. Good. Now your question, why you have this one? Usually, if you push this one here, this goes down, this goes up. So what do we have here? Yeah, remember we have MBA, we don't have the reactions yet. And MBA is nothing. We calculated this. We calculated the end moment. So I have this one like this. I have this one like this. I have the distributed load here. And I have concentrated load here. 60, and this one is 20, 10, and this is 6, and this is 5. So we said this is A, B, B, C. B, C. So what's MBA?
50.12.
Positive, it means clockwise. 50.11. What's MBC? Negative, it means counter. How much? Same. Good? Same. So, what's the reaction now here? What's the reaction here? Now, if some of them want to equal to 0, some of them want to equal to 0, we have 60 times 2.5, 50 goes counterclockwise. This and this, they are counterclockwise. Right? So this one, the shear here must be up. Some of them want to equal to 0. I have 60 times 2.5, I have 50.11, both clockwise. Then the shear times the length must give you the same moment. So the shear will be 60 times 2.5 plus 50.11 divided by 5, which is exactly 40. Sum of the force in the y direction equal to 0. I have 60, I have 40, so the reaction is 20. Likewise. By the way, يعني you don't need to do this. Let's do it. And you can come here now. Once you know this, you can come find this and that. You can come find this and that. Let's, here, look. Sum of the moment here equal to 0. I want to see what's this reaction here. So I have sum of the moment here equal to 0. I have 10 times 6 times 3. That's this way. Look. And the 50 is counter. So 60 times 3 minus 50.11 divided by 6 gives you this. Should be up. How much? 21.6. Sum of the forces in the y direction equal to 0. 60 minus this number give you this number, which is 38.4. Those are the shear to the left and shear to the right. Shear to the left and shear to the right. What's the reaction? Is the sum. مجموع اثنين. This reaction here is this plus this. Now how you have is the sum. Should be down, right? And those are up. At the joint, as he's saying, this is down. Now this is up, this is down. Now you have the reaction now. And you can check it from here. You can check it. How much this one? You are certain about this and this. 20 and 21.6. Right? Sum of the forces in the y direction equal to 0. 60 plus 60 minus those two give you the reaction at P, which is 0.4. 78.4. And you guys can easily draw the shear and diagram. The shear diagram will be 20, no change, minus 40, no change. Go to the reaction 78.4, then go down here to 20.6, then go here. Then the moment will be 0 here, positive area, negative area. So this is what you have for the moment. How is the look of the moment? كيف شكل المومنت يا شباب؟ شكل المومنت. Span AB, does it have positive or negative moment?
0.
Span AB, moment. It will have positive. Get it. This will be 20 constant here. So this is positive area. 20 times 2.5. So we know there's a positive moment here. Then there is a negative moment here. We don't know how much. There's a negative moment here. We don't know how much. ولا واحد بيعرف. 50.11. We calculated this. 50.11. So usually, always if you have to span, this has negative moment. Moment, please. Good. Then that one is linear. Good. Then start curving. See the linear line here has the same slope as this slide. Not the same. Here we have 40 for the linear, and here we have 38.4 for the curve. And you can easily find this and this. Take cut and take moment equal 0, take cut, take the other, so you can find this. So this area has negative moment. The reinforcement at the top. Here and here, positive moment. Reinforcement at the bottom. Next lecture, I'll show you how we take care of this. Next lecture, I'll show you this. You have an overhang.